we did many problems with the fitting curves. Do you remember that?
Yep.
Yeah, let me remind you about the fitting curve. It says we need to find some polynomials, right? The graph of which pass through some points, some data points. So like if you have some data, if we just consider R2, so let's say x1, y1, x2, y2, and x3, y3, or maybe more, right? Let's say x4, y4. Let's just consider 4 points. So if we have only 3 points, we can find those 3 points will help us to find a polynomial, a quadratic polynomial. We can find quadratic polynomial ax squared plus bx plus c, right? The graph of which of this parabola will pass through these 3 points. Makes sense? So we are good because when you plug, x1, x2, x3 into this equation, and here's x1, you get px1, that means y1. So you have one equation, you plug x2 into this, put this equal to y2, you get second equation, x3 into this, put it equal to y3, you get the third equation, so you are good. System of 3 equations, right, with 3 variables. So we might hope that we have some parabola. But again, right, there's no guarantee that the system will have solution. Make sense? There's no guarantee. Even the system of 3 variables with 3 equations. Anyway, let me write it down, right? Let's say ax1 squared plus bx1 plus c equal to y1. Ax2 squared plus bx2 plus c equal to y2. And ax3 squared plus bx3 plus c equal to y3. And if you have one more point, so I can write ax4 squared plus bx4 plus c equal to y4, and so on, right? And so on. So, basically, if they give you a data set and they ask you to do something like that, you need to solve the system of linear equation. All right. So I hope you remember. Okay, who can tell me, please, when a system has solution?
It has a solution if the rank of the matrix is equal to the number of non-zero, or equal to the amount of rows.
No. The rank is good. The rank is good word. But if you write this in the matrix form, right? So you would have one, the coefficient matrix A in here, and another one is just the 3 columns. So I just write that is B, right? And then from here you can get the row echelon form. Make sense? The row echelon form, right? And in the row echelon form, you calculate the number of non-zero rows. And that is the rank of the row echelon form. Make sense? But, in this form, you have 2 row echelon forms, or at least you have 2 matrices. The row echelon form for matrix A and the row echelon form for the whole. Make sense? So if the rank of the row echelon form from A will equal to the rank of the row echelon form with the bigger one, then the system will have solution. But if the ranks, if 2 ranks are not equal, so the system does not have solution. Make sense? In that situation, if the system does not have solution, like x equal to b, right? If the system does not have solution, so I have to find the closest point. Or I have to solve the following problem. The minimum of, ax minus b. I have to find x such that this value is minimum. Make sense? So let's close this one. So that is our least square problems. Okay, this is our least square problems. Suppose that the system does not have solution. If the system has solution, so the solution would be the solution of this problem, because the minimum of the norm will be 0, right? But if the system does not have solution, so we have right to find the minimum of this value, where f is just vectors, right? In this case, in R3. Okay? Make sense or not?
Yeah.
All right. So let's do one example, and then we'll see. We will try to figure out how that works, okay? And then in our textbook, there are a lot of least square problems with different constraints. So I don't know. I don't know, but if we can do all of them, but we try to go as much as possible. Okay. Let me rewrite the problem in here. So we suppose that this system does not have solution. Okay. We need to find x such that this is such that it is minimum. Okay, this is the minimum. That is least square problem. All right. So let's consider the following example. We have find the solution of the least square problems. So your matrix look like this: 1, 1, 1, 2, 1, 3, and here is C0, C1, and here is 0, 1, 3. So you can see from here that actually C1, C2, right? The two parameters in here, C1, C2, means our polynomial is just a straight line, linear, right? Because we have only two variables. And data set. So we have three equations in here. Is that correct? Yes, so since we have three equations, probably we have three data points, right? And they ask us to find, here we have two columns. That means corresponding to C0 and C1. Or I can write in the following way: we need to find C0 plus C1x. Okay, we need to find this guy that fits all data, right? So the first one is x equal to 1, y equal to 0. The second one is x equal to 2, y equal to 1, and the third one is x equal to 3 and y equal to 3. Make sense? So basically, we have 3 points. Let me express in here: x equal to 1, y equal to 0, x equal to 2, y equal to 1. That is second point. X equal to 3, y equal to 3. That's the third point. So since they are not on a straight line, right? You need to find a straight line that fit most to all of them. Agree? Okay, so how to solve this problem? Let's solve this first, and then we figure out why we need that. Okay. So in order to solve this problem, so we can say, yeah, actually this is the matrix A. Okay, this is the matrix A. Now I will calculate A transpose. First step, I will calculate A transpose. So who remember what is A transpose?
Just A rearranged, right?
The transpose means you write rows in columns and write columns in rows. So that means if this matrix is 3 by 2, the transpose should be
2 by 3.
2 by 3. So you just convert it, right? You write in the following way. This first column will be the row, so I have 1, 1, 1, and the second column will be the second row 1, 2, 3. So that's first thing. I just need to find the transpose of this. Okay. Secondly, I will calculate the product of A transpose and the A. Okay. The second step, I need to calculate A with A transpose with A, or A. I think we don't have right to write A, the A transpose with A. Make sense? So let's calculate this, and then we'll see. Let's say A transpose. I get from here. We have, A transpose is 2 by 3, right? 2 by 3. So you have right to do 2 by 3 with 3 by 2. That's good. You get 2 by 2 matrix. You get 2 by 2 matrix. So the first with the first, I get 4. I get 2, and then no, this one with this one will give me 3, right? 1 with 1 plus 1 with 1 plus 1 with 1 is 3. And then I take the first row with the second column here. 1, 2, and 3 will give me 6, right? Make sense?
Yep.
And then 1, 2, 3, 1, 2, 3, 1, 2, 3. I get 6 in here. And then 1, 4 is 9. 5 with 9 is 14. So that is my AT&T. Okay. And then now. The next step, I will calculate. I will apply AT to the B. I will apply AT to the B. It's the first step. I will apply AT to the B. Okay. So you just multiply AT with the B. You get the following one. That means I have to write 1, 1, 1 in here. 1, 2, 3 in here, apply to 0, 1, and 3. So since this is 2 by 3, this is 3 by 1, I get 2 by 2, 2 by 1 matrix. So 1, 0, 1, 1, 1, 3 is 4. And here 0, 2, and 6 is 8. It's AT with the B. Agree? And then, I have that vector. So the last one is to solve the following system. And the last step is to solve the following system. I get this matrix 3, 6, 6, 14, and then I solve for 8. I solve that system. So once I solve this system, I will get the answer. Let's solve that, and then you will see. We will revise the whole process. All right. So for this one, I will multiply by 2, right? I will get a reduced row echelon form. I multiply this by 2. I get this one just 0. I make this 0. I don't know if you can see this or not. So I get 3 in here. Even we can see. No, we cannot simplify. It's a 4. And then you get 0 in here, multiply negative by 2, add to this, I get 2. And here multiply by 2, add to this, I get 0. No, it seems strange to me. I think I get wrong here. Here should be 11. Here should be 11. Is that correct? Like 1, 2, 2, and 9 is 11. Oh my goodness, you don't see that?
No.
No.
Why don't you tell me about it? So you see, this is 4, right? 1 with 0, 0, 1 with 1, and 1 is 4. So here I have 1 with 0, 0, 2, and then 9. 2 with 9 is 11. And then we solve this. Here should not be 0. I multiply this by negative to add to this. I get 0 in here. Negative to add to this, I get 2, right? Negative to add to this, I get 3. So from here, I can solve for the second parameter. I will get 3 over 2, right?
Yep.
The first one will be 3 over 2, and then I substitute back to the first equation. I will get, sorry, we don't have much explaining here, so I have to write like this. The first one, that would be C1. So C1 is 3 over 2. And then from there, I get C0, so you can solve C0. This is 1 over 2. So I have 1 in here, I have 3 over 2 in here, right? And then I multiply this by -6. By -6, add to this. You see that? I multiply this by -6. I add to this guy, I get 0 in here. This guy with -6 will be -9. 9 plus 4 is 95. Make sense? So I have 95 in here. And then the first, for C1, that is 3 over 2. But for C0, I would get 95 over 3. And then that is our solution. That is our solution. So basically, you know, that is the X star. That is the X star, which make this value minimum. Okay? Please look at this one more time before I explain, you know, the why do we need to do that? Make sense or not?
Yeah, that makes sense.
Okay, look at this. You know, why do we need A star in this situation? Let's go back to the very first of this. Okay, why do we need A transpose? So we want to find the X, which is very close to the solution set of homogeneous system, right? That make this guy minimum. So I would do the following one. If I apply AT to both sides of this guy, look at this. If I apply AT to both sides, you see, let me erase this, okay? So you see, actually, there's from here I apply AT to both sides. I get AX equal to ATB. You see that?
Yep.
That is the first ATA. That's what we did in here, right? And the second one, ATB. That's what we did in the third step. And in the last step, we have that is the just equation of this system. That is the one right here.
Can you go over what you did in step 3 one more time?
Okay.
3.
We need to, this system does not have solution. Okay. We want to find X, which is minimize the difference between X and B. That is our purpose. It should minimize the distance between X and B. Make sense?
Yes.
All right. So how do that? You know, we apply AT to both sides. We get ATAX. Okay. So ATAX in here and ATB in here. Okay. So you get some system of linear equation. Make sense? And then if you solve this system of linear equation, you get the solution of your least square problems. It looks very simple. Agree? What we did in here is just in steps. The first step, I apply AT, I get AT, right? And then I apply ATT, ATA for this one. Make sense? And then once I finish with this, I apply AT to B, I get this vector. Agree? And then finally, in the fourth step, I just solve this system of linear equation.
Okay.
Make sense?
Yes.
Yeah, that's it. You know, that is very, you know, like very simple least square problems. Okay? So, you know, let's do one more example. And then I think it's okay for today's lecture. just warm up a little bit. So let's solve least square problems for the following system. That is for A equal to 0, 2, 3, 0, 1, 0, and then B equal to 1, 1, 3. 113. So I think we can do that directly in here if you want. So if you don't want, you can write steps like I did. So let's find 80, right? Let's find 80. 80 is 0, 3, 1, 2, 0, 0. Okay, and then find 88. Just product of this 2, 0, 0. Multiply with 0, 2, 3, 1, 0, 0. Okay, so let's find this product. It should be 2 by 2. So 0, 9, 9 with 1 is 10. 0, 0, 0. Wow, looks good. 0, 0, 0 in here. And then 2, 0, 0. 2 with 2 is 4. So that is, you know, AT&T. AT&A. That's what on the left hand side. And then you find the right hand side part, just AT, B, that is 0, 3, 1, 2, 0, 0. And here you get 1, 1, 3. Okay, so you get some vector, is 2, 2. Maybe it's just 0. 3 with 3 is 6. 1 with 2. So you get 6, 2. All right. And now you just need to solve, you know, the system. That is 10, 0, 0, 4. And the free coefficient is 6, 2. That's it. Make sense? So it's very simple. From here, you just divide by 4. And from here, you get just divide by 10, you know, the whole equation by 10. So you get 1, 0, 0, 1, and then 6 over 10, and then 2 over 4, which is 1/2. So from here, you have the solution right away. The shed line that fixed, you know, that fixed most to this all 3 points. Fixed mode for this, it should be like the first one is 6. So 6 over 10 plus 2 over 4. X or 1/2. Sorry, yeah, you can simplify that, but I can write that is 305 and then plus 1/2 x. Okay, is it clear now?
Yeah, that makes sense.
Yeah. Do you need me to solve one more problem before we finish? If you want, we can do 3 by 3. It's just shed line. Let's do 3 by 3, okay? And then we finish for today.
All right.
All right. But you know, the main idea is this. The main idea is this. Okay, we had following problem. The table shows the world population in billion. Okay, for 6 different years. Okay, so we have table. Let me write in here the year, and then the P population Y in 1985 and 1990, 1995, 2005, and then 2010. And this is 4.9, 5.3, 5.7, 6.1, 1, 2, 3. I think I mixed one in here. 0. And here, okay, let's say 0 and then maybe just 5. Just give one year, okay? 5, 7, 6.1 and then 6.5. Okay, so we have 5 years. We have 5 years, all right? And then they ask us, you know, to find the quadratic polynomial px equal to yx squared plus px plus c. That fits most, you know, to those data points. How about that? So if you, and then, you know, here's the focus, right? You don't have to use those big numbers. Make sense? Who remember, you know, how to change that? Like if you calculate 1, 2, 3, that's good. But you don't have to plug 1985 into this polynomial, right? Is that correct?
Yeah.
You don't have to. You may simplify that number, make it smaller, right? But the scale in his 5 years, is that correct? The scale here is 5 years, so you can make that a little bit more smaller, and then you know you set up, you plug everything into this equation, you get a system of linear equation with 3 variables, but you have 5 data points. So basically, you have 5, you know, 5 equations. Agree? So once you have 5 equations, so you can try to do that. You make matrix A, you find AT, and then you apply AT to both sides. Ax equal to B, and to solve for the x, and x would be the solution. I hope that the idea of solving this is clear enough. So I would suggest you this problem as homework. How about that?
Yeah.
Okay.
Okay, I would suggest you as homework. So please solve this problem and then you know send to me as soon as possible. And next time we will continue. I might solve this problem on Wednesday. Okay, and then you know we just continue this, and then we might consider another least square problems. All right.
Okay.
Sounds
Okay.
good.
Anyway, I already I have recording in here, so I will post a video on YouTube channel. So in case if you need it, you just go to my YouTube and then watch it. All right.
Sorry.
Yeah.
All right. Sounds good. Yeah. Be safe and see you next time.
Yes, sir.